Here's 2017 question 4. This looks like a separable differential equations problem, okay? Okay, so I noticed that they give me a differential equation there. Okay, they give me an initial condition. And they give me a little fact right here. Okay, that the internal temperature will always be greater than 27 degrees. Okay? All right, here we go. Part A, equation of a tangent line. You need a point and a slope. So first off, people tend to get a little bit stir crazy because there are no x's and y's. People will freak out. So here's what I generally do. We normally write things as x comma y, and in regards to slope, we have dy dx. Notice how instead of dy dx, we have dh dt. So really our point should look like t comma h. Okay? I usually do that first. Most kids tend to find that helpful, so I'll leave that up to you guys, okay? So we need to know what the point is. So we know that t is equal to 0. Now at time 0, do I know the internal temperature of the potato? In this case, it's 91. So all we're missing is the slope, which is really just the derivative. So if I plug in 91 in here, okay, you should get negative 16 if you do your math right. So that's going to be y minus y1, but in this case it's going to be h. So it's going to be h minus h1 equals the slope times t minus your other t value. Okay, so if you move this around, technically you can leave it there, but they do follow up with another question. They ask you to use this equation to approximate. So what I'm going to do here, I don't have enough space. I'm going to move that 91 over, and then they're going to ask you to use this equation to approximate the temperature when time is 3. So you just plug in 3. Equal is equal. You could just leave it there. They don't ask for units, so we're just going to move on. Okay, here's part B. Part B is asking you to find the second derivative. So here we go. The second derivative, what I would do first is I would just distribute that negative 1/4. You should get this. Okay, the derivative of that is just negative 1/4, but with respect to h. In that 27 over 4, the derivative of that is just 0 because it's a constant. Then you're going to divide that by dt. This right here is your second derivative. Okay? dh dt you guys already know, so you plug it back in. dh dt is just negative 1/4 h minus 27. Okay? So how do you know whether the estimate is over or under approximating? You're going to plug in h when t equals 3. So when you estimated it, and I'm going to go back to the scoring guidelines here, the estimate was 43 degrees when t was 3. Okay? So we're going to plug in 43 here. Okay? Now, we don't need to compute all the way through, but the second derivative here is going to come out positive. I'll give you guys a second to think about that, okay? We know that the second derivative will come out positive. What does it mean when the second derivative is positive? You know the function is concave up, meaning your tangent line approximations are going to be under. There you have it. Okay, you know it's going to be an underestimate. Okay, here's the last one, part C. They ask you to pretty much, let's see, alternate model. They give you dg of dt. G of 0 equals 91. Find an expression for g of t. Okay, so we have to integrate dg dt, which is this. Actually, let me start over. we have to separate this. So dg dt will equal negative g minus 27 to the 2/3. So we're going to multiply both sides by dt to get all the dt's on the right. And then I'm going to move this g over. I'm actually going to leave this tiny little negative right there. Okay, so here we go. We're going to have the integral of g minus 27. Now, if you move this up, it'll be negative 2/3 dg. Okay, on the right side, you're going to have negative dt. Okay, then you're going to have to integrate both sides here. You're going to get negative t. And over on the left, okay, so since the inside quantity is simple and linear, you can actually use substitution. So that'll just be g minus 27 to the positive 1/3 over 1/3. Okay. And my son just interrupted, so I'm going to leave the rest for you guys to finish there, okay? But look at the scoring guidelines and let me know.